So let's have a look at languages, because languages really are a much better way of designing things. And with software, originally software just consisted of ones and zeros, and that's what you had to write. So in the early days of computing, so devices like this, there were literally switches on the front of the computers, and you had to use those switches to enter the program. And you obviously wouldn't want to write lots of code that way, so typically there would be a bootstrap that you'd use from another source to get you started. Assembly language was invented to make this process easier, because it allowed you to enter binary instructions in a more human readable form, and that's still used in some special applications today. But a language makes things much easier, and there's a lot of languages to pick from if we're talking about writing software. Over 400 in fact, and the list is still growing. And some old, some new, used for different applications. But if we filter out ones which were originally just used for embedded systems, it's fairly small. So languages like Ada, PLM, Forth and Erlang. And that was followed by more recent languages such as C, C++ and Java. Moving forward to today, then that list has increased, so you might recognize some other languages like Python, and the list may still grow in future as well. But let's take a look at historically what we had. And there's a list of languages we're going to cover here, so C, C++, Java, JavaScript, Python and Lua, and we'll take a quick look at what each of them offer. So C's been around since the 1970s, so originally developed by Dennis Ritchie while he was working at A&T Bell Labs, and it was intended to be a general purpose programming language. So it wasn't actually intended for embedded systems as such, it was suitable for all types of computing, and it was designed to be a general purpose language that was more productive than assembler. It's still the most common language that's used for embedded today, and we can think of it as being a high-level language that has low-level capabilities that make it ideal for controlling hardware. It's powerful, but with that power it's also dangerous, so you need to know what you're doing. C++ was developed from C, and it's really the most successful object-oriented implementation of C, at least in embedded systems. And initially it gained in popularity because it was very easy to create a C++ compiler, because it was just translated from the C into C using the C-front application. It's really intended for larger projects where object-oriented languages give you a better way of managing the complexity, such as with classes. Java is another sort of C-based language, so the syntax is very similar. It was developed by Sun, who are now Oracle, to enable portable embedded code, and the initial use was mainly for things like internet applications. It's used in embedded systems, and there are even real-time variants available, but again it's really intended for larger systems. One of the advantages, it's very good for post-deployment applications. You can add code once your product's out in the marketplace. It's widely taught in universities, so a lot of people have learned the Java as their first real programming language, and it has some strong similarities with C++. JavaScript has absolutely nothing to do with Java, it just shares a similar name, and we can think of JavaScript as being an assembly language for web applications. It's used to create functionality on web pages, and it also appears in many handheld devices as well. Python is often just thought of as a scripting language, but it's really much more versatile than that. It's an interpreted language, so just like Java, it runs on a virtual machine, and it's really sort of designed with a minimalist philosophy, but it has a very wide range of libraries, which makes it really useful. And for microcontrollers, there's even a variant called MicroPython specifically intended for use with small applications. The final one on our list, Lua, is another scripting language. This time it was written specifically for embedded systems. It's designed to be small and portable. It's open source, so it's easy to learn and use. And there's a simple example there of some Lua code. And it has some similarities to Python. it's been successfully used in some small embedded systems for things like web servers. Now let's take a look at the hardware side of things, because there's also hardware description languages used for creating hardware. These are used for designing, synthesizing, verifying hardware, and the most common are Verilog, System Verilog, and VHDL, and they are very similar in some respects to traditional software, in the sense that Verilog and System Verilog are based on C syntax. VHDL uses Ada type syntax. There are some other languages that people have used over the years, typically based on C as well. Now, marketing people sometimes suggest that since VHDL and Verilog and System Verilog look like software languages, then it makes it easy for software people to start using those languages to design hardware. Unfortunately, it's not quite as simple as that, because even though hardware description languages get their syntax from C or Ada, they have very different semantics because they need to model the concurrent nature of hardware systems. So if we take a very simple bit of Verilog as an example, in this case we have some code with some variables A, B and C. So we're assigning A with a value of 10, assigning the value of B from A, and then finally writing B into C. Now, the way that this works may surprise you in the sense because at the end of that block of code, you might expect the value of C to be whatever the value of A was, which is 10, but that's not guaranteed. Because this is designed to represent hardware, then the assignments to A and B happen concurrently, so C might not be B, might not be 10, because it may get the value of the old value of A before it was updated with the value of 10. So hardware description languages work differently to traditional languages like C. What about system design? System design is often sort of proposed as a better way of implementing systems because you don't need to worry about the low-level details. For system design, the sort of most common language that's used is SystemC. However, that's typically used for design and verification. It's not used for implementation. And if you lift up the lid on SystemC, it's actually just a set of C++ classes, but it's an IEEE standard, which is part of the reasons why it's become so popular. And in fact, you can use SystemC to create hardware. So there are tools known as high-level synthesis tools that can generate Verilog RTL code from the SystemC or C++. Okay, let's move on to have a quick look at what the future might hold for us. And we may expect to see new programming languages in the future. And one in particular that's currently generating a lot of interest is Rust. So Rust looks like it may one day even replace languages like C or C++, but as I say, it's still very early days for that. So maybe we'll talk about Rust in another webinar. You might have also heard people mentioning that perhaps programming is dead. Perhaps there are better ways of actually implementing embedded systems. Visual programming has often been listed as a better way of doing things, but it never quite seems to arrive. One technique that is here today is UML, the Unified Modeling Language, and that's a high-level approach where you can draw diagrams and represent your system, and there are even tools that can generate code from that, so output C or C++ or whatever. Haven't come across anything that will do the same thing for hardware, but you never know what might be around the corner.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of David's webinar, Why C is the Language of Embedded, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.